So when we differentiate the function, we are actually finding the derivative of that function. And the derivative of a function is just the gradient or the slope of that function. It is also the gradient of the tangent line to that function at a certain point. But before we can talk about the rules of differentiation, I want us to look at the notations that we use in order to denote derivatives. So we can have y prime, we can have f prime of x, we can have the derivative of y with respect to x. We can also have the derivative with respect to x of a certain function f of x. And we can also have the derivative of a function f of x. Now, what you need to know is that we actually have one rule for differentiation. And considering how young you are, we don't really have a name for it. But when you grow old, when you get to university, you learn that we actually call it the power rule. So this is what it says. We need to let f of x to be a certain function, ax to the power n. In other words, your function has to be a polynomial or it has to be a power function. So examples of power functions, x to the power 2, x to the power 10, and so forth. Now, if this is how we define the function of x, then this is how we find the derivative of f of x. We take the exponent and multiply it by the coefficient of x. And then we take x, then we subtract 1 from its exponent. You can also write it in this form and say the derivative of ax to the n, it's just going to be a times n, and then you have your x there, you subtract 1 from the exponent. Now you need to know that this rule, it further has 3 more rules, in fact 4. It says you can't differentiate for as long as you have brackets. You need to destroy brackets, either by using the FOIL method or using the distributive property. You also can't differentiate if you have root signs. It can be the square root, the cube root, any root sign. In order for you to destroy the root sign, you need to remember what we taught you in grade 1. We said to you, every time you have the nth root of x to the power m, this is actually x, which is raised to the m over n. You need to remember that. You also can't differentiate if you have algebraic fractions. So you need to destroy the fraction. You need to separate your fraction. Or sometimes you might need to factorize, but you have to destroy the fraction. That's the most important thing. And you also can't differentiate for as long as the variable you are differentiating with respect to is in the denominator. So you have to take it to the numerator and write it in negative exponential form. Do you see that? Right. So let's say you are seated peacefully in the exam, minding your own business, and they ask you to differentiate the following function. They say to you f of x equals 2x to the power 5 minus 3x to the power 4, and then you say plus 8x. Well, here you can see that you have a polynomial you can easily use your power rule. So you say, okay, fine, in order for me to get f prime of x, I take the exponent and multiply it by the coefficient of x. So 5 times 2, we get a 10. And I need to subtract 1 from the exponent. I come to this part and do the same. I say exponent times the coefficient of x. I get 12. And then I subtract 1 from the exponent. And then I come to this one. And then I say, well, the exponent of x is 1. So 1 times 8, we get an 8. And then we still have our x there. Then we subtract 1 from the exponent. And then we get a 0. But we know that anything raised to the power 0, it's just going to be 1. And 8 times 1 will just be an 8. Do you see that? So I'm just going to give you a quick tip. Every time you have functions of this form, and you need to differentiate this, think of this as a straight line in the form mx plus c, right? So you know that your m is the gradient. So you can safely say, well, the gradient here is 2, or the derivative is 2. And here you can also say the derivative is 4. Similarly, it's just 8x. So you can say the gradient of 8x, it's just going to be 8. Do you see that? But let's say, for instance, they also added a 5 there. You need to know that 5 is a constant, and the derivative of a constant, it's just 0. Are you there with me? Of course you are. Now let's proceed to the next question. So let's say they give you a function. They say to you, you have y equals 3x squared minus 7x, and then you say minus 6. And everything here is divided by x. Well, here you can see that you have a fraction. You need to destroy this fraction. The best way for us to destroy this fraction is to separate the fraction. So this is what we say. And then we come to the first part. We say x squared divided by x. When dividing powers of the same basis, we subtract the exponents. So we get 3x. Then we go to the second part. Well, since they have the same exponents, the x's will cancel out. And when they do, we are left with a solid 7. But now this one, we can see we can't really simplify it. It's already in its simplest form. But we remember the power rule says you can't differentiate for as long as the variable you are differentiating with respect to is in the denominator. So we have to write this in negative exponential form. And this is how it's going to be. So now our function is ready for differentiation. And it's up to you which notation do you use. You can choose to say y prime, or you can choose to say dy dx, the derivative of y with respect to x. But you have to say one of these two. So you come to this 3x and differentiate it. We just gave you an easy trick. You say derivative of 3x is 3. And then you come to the 7. You realize that it's a constant. So you say the derivative of a constant is 0. And please make sure you write this 0 when differentiating. Otherwise, you can lose a mark because they're going to assume you didn't differentiate the 7. And then you come to the last part, you apply the power rule. So you take the exponent and multiply it by the coefficient of x. So -1 times -6, you get +6. And then you subtract 1 from the exponent, so you get -2 then. And this is the derivative of your function. But if they ask you to simplify it and write it in positive exponential form, then you are just going to say, okay, I have 3 there, and then I say plus. I know that the x squared has to go in the denominator, and my numerator will just be a solid 6. And your happiness is complete for this one. Now let us proceed. Let us advance. Let's do challenging stuff. Otherwise, what's the point? Well, it's pointless. And the word pointless means the point is there, just that it's less. Imagine. So let's say for reasons known to themselves, they decide to ask you to differentiate the function. They say find the derivative of y with respect to x. If it is given that y equals 4x squared minus 9, and this is divided by 4x plus 6. And here they give you a restriction. They say the value of x cannot be -3/2. Because when x is -3/2, the denominator will be 0. And division by 0 is undefined. But now one thing we can realize in this case is that we have a fraction and we can't really separate this fraction. Separating this is not going to help us in any way. Okay, fine. Let's say you choose to separate. Now the question is, where to from here? Do you see that? It didn't really help us. So the best we can do for this one is to factorize. If we look at the numerator, it's the difference of 2 squares. And in the denominator, we can easily take out the highest common factor, which is 2. In order to factorize the difference of 2 squares, we need to open 2 brackets. And we say factors of 4x squared, it's 2x and 2x. Factors of 9, it's 3 and 3. And since it's the difference of 2 squares, they have to be opposite in sign. And after taking 2 out as the highest common factor, we simply get 2x plus 3 inside the bracket. And these 2 will cancel out. And after they cancel out, we are now left with 2x minus 3 divided by 2. Well, even in this case, we still can't differentiate because we still have a fraction. So we must separate our fraction. So we have 2x over 2 minus 3 over 2. And then we can see that the 2's will cancel out. And when they do, we are left with x. And then we have 3 over 2. Now our function is ready for differentiation. So we can just say the derivative of y with respect to x is going to be what? You come to this function, you understand that the coefficient of x is 1. It means the derivative will just be 1. Or if you like, you could have said, well, in order for me to differentiate x, I understand that the exponent is 1. So I say exponent multiplied by coefficient, I get a 1, and I still have my x. Then I say 1 minus 1, which is just 0. And then I say anything to the power 0 is 1, and 1 times 1 will just be a 1. But do you see it's a long process? So there's actually a shortcut. And then you say the derivative of 3 over 2 is just going to be a 0 because it's a constant. And then you can say, well, therefore, the derivative will just be a 1 over and out. Did you see that? Now let's give this one a good look. So even in this case, we still want to find the derivative of a function, but this is how it's given to you. It's the derivative with respect to x of x plus 2 over x, and this is multiplied by x minus 2 over x. So here we can see brackets, and we can't differentiate for as long as we have brackets. So we need to destroy them first. And the best way to destroy them is to use the FOIL method. So we multiply the first terms, we multiply the outer terms, we multiply the inner terms, and we multiply the last terms. And for this notation, because we are not yet differentiating, we still keep our d dx, and we still keep the bracket, the big bracket. So x by x, we get x squared. X by 2 over x, well, we can choose to write it as x times 2 over x so that we can see it clearly. And then we say 2 over x times x. We can write it as x times 2 over x. And then we say 2 over x times 2 over x. We get negative 4 over x squared. We are not differentiating, so we still keep the notation. And then we have x squared here. And we know that the numerator of x is just 1. What I'm trying to make you aware is that these x's will cancel out. And for this one, we are left with negative 2. For that one, we are left with positive 2. And we know that negative 2 plus 2, it's just going to be 0. So we can choose not to write this. And then this negative 4 over x squared, for the purpose of differentiation, we need to write it in negative exponential form because we can't differentiate for as long as the variable we are differentiating with respect to is in the denominator. Now we are ready to differentiate. So we just drop the notation. We say equals, and then we say derivative of x squared. We multiply the exponent by the coefficient, so we get a 2. And then we subtract 1 from the exponent. Then we come to this part. We multiply the exponent by the coefficient. So -2 by -4, it's +8. And then we subtract 1 from the exponent. Well, if they ask us to write this in positive exponential form, then it's just going to be 2x plus 8 over x, which is all cubed. And your happiness is complete with this one. Well, of course, guys, you are still writing your equal signs there. I just don't like equal signs in expressions, but yes. Awesome. Now let's move along. So in this case, the aim is still the same. We still want you to find the derivative of a function. Do you see what I'm trying to achieve here? I'm actually orienting you to all the notations that we use for differentiation. And I'm also taking you through every rule of differentiation. When you have brackets, when you have fractions, when you have variables in the denominator, as well as when you have root signs. But you haven't seen the root signs as yet. You are about to see one now. So here you have 7 times the cube root of x squared. And this is added to 2 over x to the power 5. So we need to differentiate this. Well, here we can see we have 2 problems. We have a root sign, and the variable we are differentiating with respect to is in the denominator. So while we are fixing this mess, we still keep our notation. And the 7 is still there, but we remember that we have the nth root of x to the power m. So this will just be x raised to the m over n. And this one in negative exponential form, it's just going to be like this. Now everyone is ready for differentiation. So we can drop the notation now. So we take the exponent and multiply it by the coefficient of x. So 7 times 2/3, it's just going to be 14 over 3. And then you come back and subtract 1 from the exponent. So you say 2 over 3 minus 1. And 1, I can write it as 3 over 3. So it's going to be -1 over 3 like that. And then I say exponent multiplied by coefficient of x. We get -10. And then we subtract 1 from the exponent. So this is our derivative. It's perfectly fine if we leave it like this. But if they ask us to take it to positive exponential form, then this is what we are going to say. I want you to know that for the first part, the numerator will be 14. But since we already have a denominator of 3, it's just going to multiply with x to the power 1 over 3. And then for this one, it's just going to remain 10 over x to the power 6. And then we can bring back the root sign. So we can say every time we see x to the 1/3, we actually see the cube root of x, because n is 3, and this is what we have. And of course, we have 10 over x to the power 6. So this is the derivative of our function, and our happiness is complete. Now let's do one more for the day, and we can go and play with other kids. So in this case, we need to determine the derivative of the cube root of x divided by 2. And then we say plus 1 over 3x. And this is squared. So even in this case, we are still dealing with a similar problem. We have a root sign, and the variable we are differentiating with respect to is in the denominator. So while we are getting everyone ready, we still keep the notation. We know that the cube root of x is the same as x to the power 1/3. And then here we just say, we apply that rule of exponents that says if you have a over b and everything is raised to the power m, this is just a to the m divided by b to the m. But if we look at the denominator, it's a product of two things there. We have a constant and a variable. Then we remember a rule that says, if you have ab raised to the n, or to the m in this case, it's the same as a to the m times b to the m. So 1 squared, it's just going to be 1. And then 3x squared, well, you say 3 squared, it's 9. And x squared, it's x squared. That's fine. Now this one, we still write it as it is. But I want you to realize that the coefficient of x is 1. So I want us to separate this and write it as -½ times x to the 1/3. It is still the same thing, but it's easier to differentiate if you write it in this way. I also want us to separate this one and write it as 1/9 times 1/x squared. Of course, it's still the same thing, just that it's easier to differentiate if we do it like this. And then we can now take our x squared into negative exponential form. I want to show you everything. So you'll just have x to the -2, like that. So now everyone is ready for differentiation. We can just drop the notation sign. So you say exponent multiplied by the coefficient of x. So -½ times 1/3, it's -1/6. And we still have our x there. And then we subtract 1 from the exponent. So we get -2/3. And then we come to the second part. we say exponent multiplied by coefficient. So -2 by 1 over 9, it's -2 over 9. And then we subtract 1 from the exponent. And then we need to write everything in positive exponential form. And for this one, we need to introduce the root sign again. So we know that since the denominator of 6 is existing, this will just be x to the power 2 over 3. And here we have a denominator of 9, which is existing already. So we'll just have 2 over 9x, which is just cubed. And to write the final answer, we know that our m is 2 and our n is 3. So we'll just say it's -1 over 6 times the cube root of x squared. And of course, we still have -2 over 9x cubed. And this is the derivative of our function. Over and out.